Een soort zo'n film of wat? Dat is extra betalen, hè. Okay. Good afternoon, all. Thank you for joining my session on the serverless cloud. I'm glad so many of you showed up, because it's very difficult competing against something called Sensi McSenseface. I really thought about renaming the presentation to serverless something, but that wasn't working out. So let's get started. I'd like to start with a very short introduction about myself. My name is Bart Blommaerts. I work at Ordina JWorks, as many of you do. And if you have any questions, remarks, or whatever, for me, you can always reach me on my Twitter handle. So, serverless. What is serverless? Now, before we get to what serverless is, I have a small question for the audience. I have a couple of concepts. IaaS. Who of you works with infrastructure as a service on a regular basis? That's not that many of you. Okay, let's try again. PaaS, platform as a service. Who works with Cloud Foundry, OpenShift? A couple of you more. Okay, great. Now, to explain serverless, I want to draw a comparison with clueless. So clueless, it means not having a clue, right? That's easy. So serverless must definitely mean not having servers, right? Well, no. It doesn't mean no servers. Our applications, they need to run on something. We're not running on DNA yet. People are investigating that, but I'm not smart enough to talk about that. So we still need some kind of bare metal somewhere. But within serverless, we try to hide the existence of servers. We will outsource the available servers. So, does it mean no more worries? Well, kinda. Since we're outsourcing the servers, we're also outsourcing the management of the servers. People will take care of instantiating servers, of doing the scaling, of doing all those jobs for us. Now, we don't need to worry about security updates, about scalability, but we're putting a lot of trust in our service provider. So we really need to think about, do we want to trust our provider with that? As I said earlier, no more servers, that's not true, but does it mean no more operations? Well, likely is that we're going to outsource also the operational management of the servers to a dedicated team that lives within the cloud provider that we've chosen. So don't we need operation people anymore? Well, again, definitely not true. We're still going to need people who do the monitoring for us, who do deployment, who look for log files, statuses, all those kind of things. So what we really could benefit from right now, if you look at the serverless landscape, is tooling. So if we have developers with like an operation mindset who want to work on the tooling regarding serverless, that's really an opportunity. There's a lot of open source projects working around this topic. So if you're interested in that, you should just definitely be looking at that. So we've established that serverless is really a poor name. And another name that's used more and more often within the community is FaaS. It's called Functions as a Service. People really like a lot of AS. We've been talking about serverless and we've been talking about what it's not. So let's talk about what are some key characteristics of serverless. One that's very important is that it's event-driven, meaning that a lot of events will be able to trigger a serverless function. For example, if you want to have a synchronous call to something, you will have actually a synchronous call to, for example, an API gateway. I have an example of that later. And the API gateway will do an asynchronous, will send an asynchronous event to, for example, AWS Lambda. You will see some examples in a bit. Obviously, there are different types of triggers, and they are really correlated nicely with the provider that you're working with. For example, if you work with AWS, you can have DynamoDB triggers, you can have S3 triggers, SNS, and all stuff like that. Another characteristic about function as a service is that you really pay per execution. So there is also a large difference between FaaS and PaaS. Within PaaS, you still need to have a server that's running all the time. With functions as a service, you're only running a server while your code is being executed. So let me give you an example. You do a request to something and it will execute a serverless function. Only during that period of execution will there be a server running. When your request is done, there is no server running anymore. So the cost that is built to the consumer of the service will be a lot less. This is really an operational benefit from a finance point of view. Now, how does this work? The serverless provider is actually going to start up a container. We've had a lot of talks about containers earlier. This is also a kind of compute container, and we don't know how long it will be running. So there have been tests and monitoring that's in place. For example, we know that AWS compute containers last for about 4 hours, but we can't trust on the availability of the containers. But we can trust on the fact that when I execute a request, I will get a response. Another characteristic of serverless is the scaling. Since there is no running server, it's very easy for the service provider to start scaling up and down. You, as a developer or as an application provider, you don't need to worry about thank you. You don't need to worry about provisioning. So there's no risk of over-provisioning something or under-provisioning something. It will just seamlessly scale for you. Another characteristic that we know from cloud native applications, from microservice, is that it is stateless. So there is no state between invocations, and that makes a lot of sense since there is no server between invocations. So if you want to have a preserved state between method invocations, you're going to need an external database, the file system, some distributed caching system. Most of us know that from a microservice world. And last, serverless functions are easier because it really mandates you that you think about one specific function. What do I want to do? Well, I only want to do one thing. It is necessary to only be doing one thing. So there's no monoliths in the serverless world. Small recap. We have less server management because it will be outsourced to a dedicated team. It will be event-driven. You pay per execution to reduce costs. Seamless scaling, since, well, there is nothing to scale. There is no running server between invocations. It is stateless. No state is preserved between invocations. And it is easier, unless you really don't want it to be easier, and you start throwing a lot of stuff, a lot of garbage together in the same function. But well, if you want to be the bad, then you can always be bad and write crappy code. Now we've talked about what serverless is. I want to talk about a couple of examples of serverless suppliers. I'm pretty sure all of you know my friend over there. Now, what we have noticed, or what I've noticed, is that all of the larger providers of IaaS, of PaaS, have really jumped on this serverless bandwagon. Everybody wants to be in. This kind of shows that there's like a need to be part of the serverless movement. And of course, they want to differentiate. So, for example, Google will integrate their serverless functions with other offerings that they have on the Google Cloud engine. Same goes for Amazon, for Microsoft Azure. So they really want to have it tightly integrated with their other offerings. I will go over the existing suppliers right now, and then afterwards we'll have a demo, and I can show you a bit of these suppliers. The first one I'd like to talk about is AWS Lambda. It is by far the most famous supplier of serverless functions. It was actually not the first one. Google had Google App Engine about 5 years ago. They started it 5 years ago, and it was also kind of a serverless way of working, but it's really Amazon who made it famous. The traction really comes from what they were offering in regards to tooling and serverless functions. As you can expect, it integrates very nicely with other Amazon services like DynamoDB. I will show that later on. And you can also, well, most of the time when you write a serverless function using AWS Lambda, you will also be using the API Gateway to execute synchronous requests to your function. Next one is IBM BLUEMIX OPENWHISK. So IBM BLUEMIX is the PaaS offering of IBM. And on top of that PaaS offering, they have implemented OPENWHISK. Now, personally, I think that OPENWHISK is a really nice solution. They have a really nice user experience. It's very easy to work with. They have nice monitoring. I'll be glad to show that later. And what's also really convenient with OPENWHISK is that it's open source. You can go to GitHub, you can download it, and you can run it on-premise. Not entirely sure why you would want to do that, but it's definitely possible. Microsoft Azure Cloud Functions. Well, as you can expect, it's built on top of Azure, and it integrates very nicely with other Azure services. Something where Microsoft is like really ahead of the game is also their integration with other SaaS services. So, for example, if you want to build a function and you want to integrate it with, for example, Google Drive, it's just a couple of clicks and it works. That's something that we don't have from other providers right now out of the box. Last of the big suppliers is Google. Google Cloud Functions. The thing with Google Cloud Functions is that it's currently in private alpha. Officially, that means that you're not allowed to talk about it. I'm a member of the private alpha, so I can't talk about it. But in my opinion, I kind of know why it's still in private alpha. They still have a lot of work to do. I don't think it's on the same level yet as, for example, BLUEMIX or Lambda. But there's a huge amount of traction in their forums. People are working on it very, very hard, and they really want to have a competitive product when it exits the private alpha status. Also, don't forget that it was actually Google that really started this initiative many years ago. Very promising. I'm pretty sure that most of you know all of the previous suppliers. One that you might not have heard of is AUTHO. They have another offering called AUTHO, what's it called again? Something for authentication, forgot it. Yeah. But they also have WEBTASK for serverless functions, and WEBTASK is really something that I specifically want to mention. There are other smaller suppliers as well, but WEBTASK is really focused on simplicity. If you exit this talk and you say, okay, I want to have a look at it, I think you should look at WEBTASK. I'm pretty sure that everybody in the room can get a WEBTASK up and running in under a minute. There's really, the ease of use is incredible. And of course, they will integrate very nicely with their security and authentication solutions. That's a lot of talking. Let's do a demo. That's always really cool to get our hands-on the code, see what's happening. And the demo that I will be doing will be regarding collaborative economy. I just have 2 very small slides to talk about collaborative economy so that you guys know what we're trying to achieve in the demo. So, a lot of the companies today, they have huge amounts of data. And very likely, they're not using that data in a cost-efficient way. It can't be just a cost center. The database, it's over there, it's a cost center. Nobody knows what it's doing. Wouldn't it be nice if you could expose that data to the world, maybe make some small public API, and yeah, maybe you don't know what to do with it, but other companies might be interested in using your data, or maybe enriching the data that you already have with something that they have, and building like an API economy around your data. Now you might say, yeah, okay, but my startup is new, we don't have any data yet, but we really have good ideas. So if you don't have any data, you can still go with serverless and collaborative economy, because you might have creative ideas. Just use somebody else's data. And there's a lot of data available. There is the Open Data project, for example, from the Flemish government that offers like tons of data that's really not used. And if you want to use it and to combine it and really use your creativity to create value from that data, that's something that you can do right now. Why do I think that collaborative economy is a very nice match with serverless? Because I really believe that serverless enables experimentation. From an operational point of view, well, serverless, it's just cheap. You pay for whatever is being executed. From a development point of view, since it's easy, since the toolset is still quite limited, it's quick. You can have something up and running in 30 seconds. Also, if your service that you just made is really being used by a lot of people, it will scale for you. Don't worry about the scaling. Let the vendor worry about the scaling. And if it's not used, well, okay, you tried, you failed, but that's really great because you can learn from it, and it didn't cost you anything, or not a lot. So in a collaborative economy, if you want to be part of that, serverless can really make sure that you're like part of the value chain. This will be our demo. Up until 5 minutes before the presentation, the demo actually was kind of working somehow. So the goal is this Arduino will be measuring the temperature in the room. It will post the request to a WEBTASK made with AUTHO, and WEBTASK will parse the incoming data add some data of its own, and then do the same. It will post the task to OPENWHISK. OPENWHISK will do the same. It will parse the information, add some information of its own, and then do new post request to the AWS API Gateway. That will send an event to AWS Lambda. That in return will store data in an AWS DynamoDB. That will stream an event to another Lambda. That will finally be logging it in AWS CloudWatch. So live demos are also really cool. So I decided to have as many moving parts as possible and really need the network to make sure that everything works. Not because I'm confident, maybe because I didn't think this through. Now everything is open source. It's available on GitHub. The code for the Arduino was actually made by the IoT guys. I don't have anything to do with that. I'm not smart enough to do that. So let's look at it. So these are the logs for the Arduino. Ah, okay. So these are the logs for the Arduino. Oh no, I'll do it like this. There are two buttons on it. One button will measure the temperature once, and the other button will continuously measure it. So let's see what it does. Oh, maybe move this so that you can see the screen. So the light went on, that's something. 1614. That looks right? 24 degrees. Okay. I'm happy to see that it works. Now, that's not really impressive now, is it? A log file? No? Okay. I expected that. Let's look at what it did. If I can find my mouse again. Here we have. So, the Arduino has built in some kind of cache that you can see all my requests. And that is showing me that I've executed, for example, you see the AZURE WEBTASK, OPENWHISK, AWS Lambda, and from there on, the request is sent to the DynamoDB and we'll go over everything. Just kind of annoying that I have to turn my head all the time. Let's see if we can fix that. It's not being mirrored right now. Okay, that's a shame. Mirror built-in retina display. How do I duplicate my screen? That looks better. Great, thanks a lot. So now I can actually see what I'm doing. Okay, so the first function that we were calling was in WebTask. It's just a CLI. It's not really has any nice metrics, but the OPENWHISK one is something that I really want to show. So this is the OPENWHISK monitoring dashboard. As you can see, it is pretty, or I think at least that it's pretty. You can see how many times that it has been requested, what the response times was. You can see the logging, and you can actually also do the development from within your browser. Anyone who's familiar with Node will see that this is just a very simple NodeJS function that's going to use request. It will add some data to a parameter that's being passed to it. It will call a URL. It will do it asynchronously, and the URL is actually AWS. What's also something that's really cool that we can just execute it from here. So if you do run with this value, so just hard-coded the WebTask from AWS. If you do run with this value, we immediately get our result, and we can see, if you look at monitoring, that it's been executed correctly. Okay. So OPENWHISK is going to call the API Gateway. So let's have a look at the Amazon API Gateway. Now, if you compare this look and feel and user experience to the one from OPENWHISK, I really prefer the OPENWHISK approach. AWS is not really known for its user experience. They have a lot of really cool stuff, but generally it doesn't look the part. This is a different Lambda that I have because it has a couple of more API endpoints, so it's prettier to look at. Now, if you want to use the API gateway from Amazon, you really should know what all these things mean, all these buttons mean. If you want just to test it, you can hit test. This particular one will be also using a DynamoDB. It needs an environment, for example, development, and then you get your response. So there's a lot of cool cars coming from the DynamoDB Lambda. Now, of course, this is just the API gateway. So this is the gateway in front of the Lambda. This will just be sent an event to the Lambda, and it's the Lambda that will be executing the code. So this is the AWS Lambda Management Console. For example, if we look at process Dynamo, this is the end one. I'll show this one at the end. Now, the first function that I made was made using a framework called Just Serverless. I really recommend looking at Just Serverless because it will take care a lot of the maybe strange things that API Gateway is expecting from you. I'm telling you this because when you use Just Serverless, it's not possible to edit the code inline. So you will need to upload a zip file, and that's just cumbersome. If you use the framework, it's a lot easier. This one in particular, for example, you see, well, it doesn't have any triggers. Obviously, I'm saying this with a reason. The other Lambda that we will look at is the process DynamoDB stream. It's the Lambda at the very end, and that is using a trigger. So, but let's look at things first. So the Just Serverless Lambda is going to insert information in the hops table in DynamoDB. So these are all the records that have been added. I'll just open one to show you guys what's happening. So it's just JSON that contains information from the previous requests. And it was 23 degrees during this execution. If we look at the DynamoDB, you will see that there's also a trigger, and this trigger will be called after every operation that happens on the database. So the trigger being executed is called process DynamoDB stream, which is the simplest of NodeJS functions that we can come across, and it will only be just logging some information. And this information will be logged to CloudWatch. So let's have a look at CloudWatch. And you will see here that I have a couple of functions running, and the process DynamoDB stream at 16:15, so that's just like 5 minutes ago, it has executed, it has logged the things that come from the DynamoDB. So is that clear? We had a couple of different hops between different functions from different suppliers, store it in a DynamoDB, and the DynamoDB will then send an event to another Lambda, and that will store it in CloudWatch. Is that clear? Any questions? No questions? Okay, great. One thing that I didn't show is the Azure Cloud Functions. And I actually didn't show it because they keep on sending me invoices for stuff I need to pay. So I removed it from the demo. With AWS and with OPENWHISK, you get like really large amount of free tier that you can use. And the pricing model of Azure is a bit different. But I will come to that in a bit. When we look at Azure and at the functions, it's in Dutch, I'm sorry for that. It will give an error because I stopped my application. You can create your new function via this wizard. You can use C# or JavaScript, and I'll show one, for example, get cars. It's going to use a table and just get some data from it. Yes, I stopped it, I know. If you look at, for example, the records that will be retrieved, they will be logged. This was one from yesterday. I really personally like the look and feel and the experience with Azure. But it's also really cool if you look at integrating your function with, for example, Azure Storage Table. You just can click on it and you have some easy to use. Yes, don't give me the error. Some easy to use fields. Now, if you prefer doing it in an editor, you can also just use the JSON configuration. Something that's currently ongoing is the integration of the Just Serverless framework with Azure, where Microsoft is actually contributing to Just Serverless so that Just Serverless can also work with Microsoft Azure, and the guys from OPENWHISK are also doing that. So Just Serverless is really something that you want to be looking at. It's actually called the Serverless framework. Their website is Just Serverless. So it will be like a vendor agnostic tool to create lambdas. Okay. That's about it, I think, what I wanted to show. So let's head back to the presentation. Are there any questions so far regarding this? No questions? Okay. Best practices for serverless functions. There are not a lot of best practices yet. This is really new. Amazon made it like popular in 2014. I personally think that this is an opportunity. If you want to be working on the frameworks, for example, like Apex or the serverless framework, this really now you can make a difference. But we don't want to end up like Walter White, do we? Regarding the supplier choice, don't do what I just did. Don't use every possible supplier out there because you feel like making a cool demo. Be very conscious when you select your supplier because you will be trusting them with your application, with your services. When you make the selection, or when you try to make the selection of a cloud supplier, look at what they're integrating with. If you're interested, for example, in IBM Watson, or you're using it today, then you should be looking at IBM OpenWhisk. Also look at what you will be using in the future, because right now all the code looks very similar. I'll go over a couple of code samples. I forgot to do that, but it all looks very similar. But it's not plug and play. They're all inconvenient differences altogether. For example, using third-party node modules is different in for example Lambda or in WEBTASK. So you need to be aware of that. Also look at their pricing. What I was just saying about Azure, the current pricing strategy of Azure is kind of different than at Lambda because they're using the term resources in a different way. So it's very important that you make a very conscious decision what you're doing. I didn't do that and ended up with an invoice that I didn't expect. Then also regarding tooling, build and deployment, monitoring, maybe I can show that also in a bit. Most of the suppliers have monitoring tools, and most of them are not really that good. Let me show you. For example, we'll start with the most famous one of all, which is AWS. If you look at the monitoring, this is what you get. You get an invocation count, you get an invocation duration. These are all kind of small, and then you don't get any errors. And as I just was saying, 5 minutes before the presentation, I had errors, so I don't know where they went to. There is already some work on that. Things are changing a lot. So, for example, in CloudWatch, you can add dashboards of your own. So I've made a serverless hubs dashboard, and you can combine all this data. But still, to me, it's not enough from a monitoring point of view. I think, for example, what Azure is doing is looking better. For example, if we look at this one, you see that okay, this method is what's being called. We see their statuses. It just feels like more natural, and we also see that the recent errors, the number of successes, we can stream it. Also with OpenWhisk, what I showed you earlier, we get like a nice overview. I just selected one function now. If you have a lot of functions, you can also aggregate them all together in one dashboard, and then you really get one page to see what's happening with your application. If we look at a productive application, when we were talking about the no more operations, I really think that if you want to put a large serverless application into production, then you should have like DevOps people who make sure that the monitoring and then everything looking up is tightly integrated within your application. It's really part of what you're building, not an afterthought, because I'm pretty sure that you will not be satisfied with the results. I also said that I was going to talk about the code a bit, so this is what I already showed with OPENWHISK. If you want to compare it, for example, with, where's my Sublime? With others. Is it still showing? Yes, okay. This is, for example, the AUTHO WEBTASK. It's very similar. You're just parsing some JSON, executing a request, but there are all tiny differences between all the things. For example, this is one from OPENWHISK. It's very similar, as you can see. But with WebTask, we didn't. I'll give it. When you with WebTask want to use a third-party module, you need to include it in your application as well. I have an example of that somewhere. In AWS, it's actually the same. So here we want to use the Node UUID just to generate general normal UUID, and you can package that with your application. Let me see if I can quickly find it. So AWS, serverless, and you just have your regular package of JSON where you can say these are my dependencies. It's very easy to use. Another thing that I really like about serverless is the possibility to configure your AWS instance from within your function. So there's a configuration file, there's a YAML file where you can say, okay, I want to have this is the region I want to use. If you want another region or more than one region, you can just add it to this YAML file and you don't need to go to the API gateway and understand everything that's going on in the API gateway. Because actually, I think that the serverless framework is more stable than what they're doing in the API gateway. They tend to move things around, and you can always find what you're looking for, but it might be called differently. So serverless the serverless framework is really something that you want to look at. The last one is the process DynamoDB stream. It will just log the event and parse some of the JSON, and then, as I've shown you, log it to the to CloudWatch. But I still believe that regarding monitoring, there are some opportunities before us. Another best practice regarding code. If you're using other services, for example DynamoDB, or you're loading modules, it's really important to load that information outside of your actual function, because it's a costly operation. You don't want to make a database connection every single time. You want just to have the object available for you. Another good reason is limit your function size. First reason of all is to keep it easy, but more important, and a more important reason is that you want to make sure that the startup time of your compute container is very small, as small as possible, because it is waiting time. And if you're doing a synchronous request via, for example, the API gateway, you don't want to be waiting for it. Also, if you're using Java, the JVM will need to start up, and that takes a lot of time. So the NodeJS function, it's like instantly available. Within if you really want to start up a JVM, it will take some time. Especially when it's like a cold start. And then also from personal experience, AWS, OPENWHISK, they really have nice editors. They have syntax highlighting, they have everything that you want. And for quickly prototyping something, it's useful to do that. But if you really want to build a real application, you should really be using an external editor. For example, in OPENWHISK, I had it earlier. All of a sudden, my code was gone. I'm pretty sure that I did something incorrectly, but it auto saves and it has no version history. So all my code is gone. Okay, and that was it. So I'm done a bit earlier. If you have any questions for me, I'll be happy to try to find an answer to them. Yes? Okay, so the question was, in what business cases do you see this architecture become useful? I think that's an excellent question. So two parts where I think it's useful if you want to look at, for example, collaborative economy. If you think, I want to quickly experiment with something, I don't know if it's going to work, but just have a quick and cheap solution to something. Another use case that I really see where I see the use of it is using IoT devices. For example, the Arduino now just sent the temperature once. That's not really a very useful use case. But imagine that you have a container park with all different kind of sensors, and you really don't know when they're going to be sending data to you. So the traffic will be very unpredictable. If you don't want to be wondering about over or under provisioning, that unpredictability is something that you can help with serverless. Now, I had a similar question by a friend now who said, well, I'm not drinking this whole serverless Kool-Aid. I don't believe that this is going to be the next big thing. And he might be right, but what we really see today is that serverless is already changing a lot of things because of, for example, their pricing model. This pay-per execution is something that we've never seen earlier. Right now, we're just used to provisioning our server. We start it up, and then during the night, it's probably doing nothing at all. So it is changing this. It might not be something that everybody will be doing in 6 months' time. I don't think that will be the case. But it really will have an influence, I think, on cloud computing in general. Okay, yes. So the question was, can you tell us a bit about what's happening behind the scenes? I don't know what's happening behind the scenes with all the service providers. There is a very nice article on the AZURE website on how they're doing WEBTASK. But for example, for AWS, they will spin up a compute container for you. It will right now last for 4 hours, but just that's black box for you. You're not aware of what's happening. If they for some reason decide that it should be 2 hours or 15 minutes, then that's up to them. And you can compare it to what's happening with Docker. If you want to run a Docker image, you just do Docker run and it's immediately available. So you're asking if do they have any guarantees regarding the response times? Yes. Yes. When the cloud container gets instantiated, for example, with the JVM inside, it's called a cold start. That will take some time, and the next invocation will be quicker. But I said earlier, Amazon is not going to keep it up and running all the time for you, so there will be cold starts, and they will be slow. Now, if you're talking about, for example, service level agreements or things like that, I think that's very peculiar question that you should ask the AWS, but in practice, well, they're not going to offer you that. That's not the use case of serverless. If you want to have immediate responses all the time for everything, then it's probably useful to really think about, oh, maybe I just want to have Docker running all the time somewhere. When we're talking about the compute containers, for example, you can have actually Docker running on OPENWHISK. So most of the implementers support NodeJS. Azure also supports C#, F#. AWS supports Python, supports Java, and OPENWHISK is really, I think, very nicely placed because they support Docker. So starting up your Docker container, then you can put whatever you want in it, whatever language, whatever operating system you want. But I don't think that they're going to give you hard SLAs on their offering. So the question was, plans to not use the cold start. That's also a very excellent question. The thing is, then the use case changes. If you want to have a server running all the time, you can get that from Amazon. You can get that from any provider. But then it's better to look at, for example, like a PaaS, where you have it running all the time, and then you pay for the entire time. So that there's like two different use cases. Okay, more questions? Yes? Continuously deploying functions. The support for different environments, if you remember, or I can show you it in a bit, the demo I did with AWS, you can have different variables that you say, for example, for my development environment, I want to use a certain table in a DynamoDB, or for production it should be another table. So that's fully supported, but it's up to you to define it, as it is in most applications. Regarding continuous delivery, there are a couple of ongoing projects that support continuous delivery for serverless functions, so that you just can commit your code and then it will be automatically deployed to your serverless. But also it's in that same manner. Most of the providers also support, for example, webhooks, and you can attach a webhook to GitHub. So if on a commit on GitHub you start your webhook, you can also deploy your code in that way. But specific tooling is being built at the moment. But as I said, this is also pretty new. It's relatively immature. You will face issues that you don't understand that magically disappear the next day, or receive invoices that magically appear. So it is relatively new. So if the question is this production ready, you should be very careful about what you do with it. So I think it can be production ready, but you really need to investigate what's your specific use case, which vendor do I want to trust, and do we have the maturity that we desire from the project that we're currently building. So this is definitely not a one size fits all kind of solution. No silver bullet. Everything will be serverless in 6 months. More questions? Okay, maybe I have a question for you. What do you guys think about serverless? Do you think, oh, this is just some kind of a techie guys who are building something really don't care about it, or this has a really an added value? This is a way we see the industry moving in. So I'm really curious to learn your impressions about that as well. Don't be shy. I have a bounty, so I'm not biting. Yes. Mm-hmm. Mm-hmm. Well, I think that that's an excellent remark. Well, the fine graining, the fine grained nature of the function might be too small, but if we compare it, for example, to nanoservices or to microservices, that it's kind of the same issue that we're addressing over there. And also the people who are building the tools are aware of this. For example, if we look at the serverless framework, they offer you the possibility to group your functions and to deploy all of them at once. So for example, if you want to do CRUD on an existing table, you can all group all of these functions and then deploy them all together. So there are possibilities in that regard as well. You can write your microservice or your nano services or whatever in a serverless function as well, but you need to think about it. The amount of best practice available is still rather small. Any other thoughts? No? Mm-hmm. Yes. Mm-hmm. Yes. Mm-hmm. But there are a lot of people who are also always mentioning when we're talking about functions as a service, who already mentioning PaaS. Isn't it the same? And there is a really nice quote about Adrian Cockcroft who says, if your PaaS can start up in 1 second, give you a response in 30 milliseconds, and then bill you for 2 seconds or for 1 second and 30 milliseconds, then you can call it fast. So this is a different use case. And both are very valuable. I definitely believe that you should be looking at that way of building cloud native or cloud applications. Okay, if there are no further questions, then thank you all for your attention.